Welcome to a series of videos on converting from moles to moles, and now we're going to look at moles to grams. So we're using balanced equations. So the previous video we talked about how we can relate the moles, our coefficients, in a balanced equation. So we have mole to mole ratios. So if you look here, we have 3 moles of oxygen for every 2 moles of ozone, O3. Okay, so we're going to take this one step further. You're going to use the same step that we used in the previous video where we converted from moles to moles, and then we're just going to add a step. Alright, so we're going to go to moles of a product. Okay, so if you go from moles of one compound to moles of a totally different compound, the only way that you can convert these and have a common relationship is by using our mole to mole ratio or mole to mole conversion factor. Okay, so we did this on the last video, and then we're just going to add one step. Okay, so if you recall from a couple of videos ago, we then convert from moles of the product and we can convert to grams. Okay, so in a previous video we saw how we convert from moles to grams and grams to moles. So if you don't remember, I'm going to show it in here. Okay, so we use our mole to mole ratio to do step 1, and to do step 2 we have to use the molar mass, okay, of that product that we get our answer here, okay, and we convert to grams. Okay, in order to do this you're going to have to multiply times the molar mass in step 2. Okay, so the problem, let's go back and look at it real quick. So we want to look at how many grams of ozone are formed from 9 moles of oxygen. So moles and grams are not the same thing. We've established that. So we're asked for grams of ozone, but we're starting with moles of oxygen. Okay, O2 and O3 are different compounds, obviously. Okay, so we need to start with moles of oxygen and get to moles of ozone. Okay, and so we can do that by our mole to mole ratio. Okay, so if we look at our mole to mole ratio, we have a 3 to 2 ratio, or we can flip it over and it's a 2 to 3 ratio. Okay, and so we're going to use this ratio because we're starting with oxygen. So we've got our 9 moles of O2. Therefore, O2 has to be in the denominator, and moles, the moles and the compound have to cancel, and there are 2 moles of ozone. Okay, so the 3 comes from here. That's my mole to mole ratio. Okay, and this is my balanced equation. Okay, so this is what we did in the previous video. Okay, but the problem, so if we cancel here, we're left with moles of oxygen. Okay, if that's what the problem asked, then we could just stop. All right, but the problem asks for grams of ozone. Okay, if we have moles of any compound or grams of it, we can always convert between the two. All right, so this is just that one step from grams to moles that we did in a previous video, and we get to moles to grams by using the molar mass. Okay, so we need to add up the molar mass. Okay, ozone is our compound here, and oxygen has an atomic weight of 16, and you have 3 of them, so the molar mass is 48. All right, so we have 2 ratios here. This is our molar mass conversion factor. We have 1 mole for every 48 grams, or 48 grams for every 1 mole. Okay, and we're going to need this ratio so that it plugs in, so that our moles will cancel. Okay, so we take our 9 moles. This is what's given to us. So we always write out what's given. We have 9 moles of oxygen, and then we plug in our mole to mole ratio from our balanced equation so that moles of oxygen cancel. Has to be 2/3, not vice versa, so that the O2 also cancels. Okay, so we're left with 2 moles of ozone. In order for us to convert to grams, we use our molar mass conversion factor. So if you're going from moles to grams or grams to moles, you always use your molar mass. All right, because moles of ozone is on top here, we have to have moles of ozone in the denominator, just like we've always done for converting. And that leaves us with grams of ozone as our unit. And that is what the problem, if you look back, the problem asks for grams of ozone. Okay, so moles cancel again, moles of O2 cancel, then moles of ozone, and we're left with 290 grams of ozone. So this is a 2-step problem using our conversion factors that we learned just as one step in previous videos and just putting them together. You have a mole to mole conversion, and then you have your molar mass conversion to get to grams. All right, I hope this helped. In the next video, we're going to put all of our steps together and put one more step into these conversions. All right, thank you.